Hello, everyone. All right, so with 7C, this is going to be factoring special cases. So this is really kind of a follow-up with 7B when we were just factoring trinomials in general. So just kind of a start off, we're going to be looking at problems that are a little just, they're not the typical problems we're going to be seeing. I'll put it that way. So we're going to start off by just multiplying two binomials together, just like before. So just kind of a quick recap. If I do FOIL for this one, I'll do the first terms multiplied together, the outside terms multiplied together, the inside terms multiplied together, and the last terms multiplied together. All right, so I'm doing FOIL here, so FOIL. All right, so in blue is our first terms, so n times n, which gives you n squared. Then in red, we have n times 4, which gives you 4n. Then in green, we have our inside terms, so negative 4 times n, which gives you negative 4n. And our last terms, which is negative 4 times 4, which gives you negative 16. All right, so what we're going to be doing is we're going to take all 4 of those terms, and we're going to add them all together. So n squared plus 4n minus 4n minus 16. We want to combine our like terms. So our 4n and 4n are going to be combined. But if you notice, those are inverses of each other. So 4n minus 4n, they're eliminated. They're gone. So all we're left with is n squared minus 16. All right. So that's the first one. Now our second problem over here, we have n plus 4 squared. So just to remind everyone, remember when you square something, if I were to expand this, I'm going to write out n plus 4 twice. So this is the same as doing m plus 4 times m plus 4. So then from here, then you can do FOIL or box method. So I'll do box method on this one, so everyone can see their preferred method. All right, so I'm going to do m plus 4 across the top and m plus 4 across the side. All right, so remember, multiply up and left. So top left, you're going to get m squared, 4m, 4m, and 16 here. All right, and then your diagonal, those are your like terms. So here, we're going to have m squared plus 4m plus 4m plus 16. I'm going to combine those like terms here. So I'm going to have m squared plus 8m plus 16. So this is going to be our final answer here. All right, so if you notice, looking at the way these binomials were set up, these are the problems that we're now going to do working backwards. These are the problems that we're going to factor. So I'm actually going to give you, say, a problem like n squared minus 16, and we want to end up with both of these, n minus 4 and n plus 4. Or over here, for example, I'll give you m squared plus 8m plus 16, and we're going to end up with m plus 4 all squared. All right. So the first one we're going to be looking at is what we call a perfect square trinomial. All right, so a perfect square trinomial would be like this example here. All right, so if you notice, both the first and the last terms are perfect squares. So hence why it's a perfect square trinomial. But now if you look over at the next one, we have what we call a difference of squares. So notice how it says difference, and in math, difference is subtraction. So over here, where we are subtracting that 16, that's where the difference of squares comes in. And both of these values are perfect squares. So a difference of squares. All right, so we're going to start off with this very first problem here. So I'm actually going to solve this one using just grouping like we did at the very beginning in 7b. All right, so I'm going to do my a, b, and c values. So a, b, and c. So my a value here is 1, b value here is 6, and c value is 9. All right, so I'm going to do a times c, which is 1 times 9, which gives you 9. All right, and then now I want to find the factors of 9. So we're going to have 1 and 9, and 3 and 3. Now remember, we want them to add up to your b value. So we want them to add up to 6. So in order for that to work, we want 3 and 3. So I'm going to use 3 and 3 to split the middle. So here, I'm going to draw my arrow going down. All right, so I'm going to have r squared plus 3r plus 3r plus 9. All right, so now I'm going to do grouping. So I'm going to group the first two terms together. So r squared plus 3r. Then my second group is going to be my second 3r, then plus 9. All right, so now I want to do my grouping. So out of the first group, I can take out an r value. All right, so when I do that, in parentheses, what I have left is I'll have r plus 3. All right, now if I look at the second group, between 3r and 9, I can take out a 3. So when I take out a 3, I'm going to have r plus 3. So now the binomials in the parentheses here, I'm going to take those out. So I'm going to write r plus 3. So when I take those out, both of these are gone. And I just have the r and 3 left. All right, so notice how they're the exact same binomial. So I can rewrite it as r plus 3 squared. So that would be our final answer. Hello. There we go. All right, so this is an example of a perfect square trinomial. So there is a trick to solving a perfect square trinomial. All right, so let's say I'll do it down here. So r squared plus 6r plus 9. Now, just an FYI, this is only going to work if you recognize the pattern. So the pattern is the first and the last terms, they have to be perfect squares, meaning I can take the square root of them. So if I take the square root of r squared and the square root of 9, if I take the square root of r squared, you get r. If I take the square root of 9, you're going to get 3. So what you're going to do next is you want to take the sign of your b value. So I'm going to have r plus 3. And then this is going to be your binomial squared. So your answer here is r plus 3 squared. But like I said, it only really works if you can recognize the pattern that the first and last values are going to be perfect squares. And then you just keep the sign of the b value. All right. All right, so now looking at this next one, let's say I just do the trick. You can still solve it by grouping if you're unsure. Like if you're not sure that you're going to recognize the patterns when all of the problems are together on paper or whatever, then you can just solve it by grouping if you're unsure. So looking at this one, k squared is a perfect square. I can take the square root of that. 144 is a perfect square. I can take the square root of that. So I'm going to take the square root of k squared. I'm going to get k. I'm going to take the square root of 144. And I'm going to get 12. Then if I just take the sign from my b value, Just keep it there. Now we're going to have k minus 12 squared. All right. So that would be our binomial for this one. So k minus 12 squared. All right. So that's for perfect square trinomials. Now if I do a difference of squares, this one's a little bit different. So just like before, I'm going to do this one using grouping first, just to kind of show you what it looks like. All right, so first off, I want to find my a, b, and c values. All right, so I have an a value of 1, a b value of 0, and a c value of negative 25. So we don't have a b value in this case. All right, so I'm still going to do my a times c. So I'm going to have 1 times negative 25, which gives you negative 25. All right, so I'm going to have 1 and 25, and then 5 and 5. Now, because they add up to 0, but they multiply to a negative, that means one of these has to be a negative. So if I do negative 5 and positive 5, those would add up to 0, but multiply to negative 25. So I need positive 5 and negative 5. All right, so that's what I'm going to use to split the middle. All right, so first I'm going to rewrite it as m squared plus 0m minus 25. So that 0m right here, this is what's being split. So we're going to have m squared plus 5m minus 5m, then minus 25. All right, so this is what we're going to do our grouping method with. So I'm going to group the first two together. So m squared plus 5m, and then negative 5m minus 25. All right, so out of the first group, I'm going to take out an m value, and that leaves me with m plus 5. Now in the second group over there, between negative 5m and negative 5, I can take out a negative 5. That leaves me with m plus 5. All right, so I'm going to take out the m plus 5. So I have m plus 5 that I'm taking out from both. So these are gone. Then I have my m minus 5 left. All right, so notice how they're the same number, but one's with addition and one's with subtraction. All right, so this would be our final answer for this problem if we did it by grouping. So full disclosure, all these special case problems on here, you can still solve using grouping that we've been doing. So you can still do it the way that we learned in 7B if you're more comfortable doing it that way. All right, so now I'm actually going to show you the trick for this one. So both of these special cases have tricks. All right, so you just have to be able to recognize when the polynomial is a special case. For difference of squares, this one's pretty easy because these problems are only 2 terms, whereas your typical problem is going to be 3 terms. So the ones that are going to be a little bit more tougher to see are going to be your perfect square trinomials because these are going to blend in a lot more with your other problems. All right, so for your difference of squares here, both values are perfect squares. So I'm going to take the square root of both of them. So if I take the square root of m squared, you get m. And if I take the square root of 25, nope, you get 5. So now with the difference of squares, you're going to have 2 binomials, one with addition and one with subtraction. However, both of your binomials are going to be m and 5. So you're going to have m plus 5 and m minus 5. It's just one's with addition, one's with subtraction. Okay, so there's the trick for that one. So if I look over here at this next one, we have 4c squared minus 49. I'm going to do the trick for this one. All right, so let's say I take the square root of the first, square root of the last. Square root of 4c squared is 2c. square root of 49 is going to be 7. All right, so remember, I want one binomial with addition and one with subtraction. And I'm just going to take those values and I'm just going to plug them in. So I'm going to have 2c plus 7 and 2c minus 7. And those are the two binomials. All right. So one thing to really emphasize here is please notice and emphasize and kind of reiterate the fact that it says a difference of squares. So a difference of squares means subtraction. So if you ever see m squared plus 25, or if you ever see 4c squared plus 49, this is a summation of squares. Summations of squares are prime. Those are not going to be anything. So you have to be careful. So if you ever see something that's plus, that's not anything. It is prime. All right. So that's not actually written in the notes. So I would definitely take a minute, pause here if you need to, and just write this in your notes. All right. So now we're going to do some practice problems. So full disclosure, all these questions on the notes and the practice are going to be special cases. So they're going to either be a difference of squares or they're going to be perfect square trinomials. So the trick will work for all of these. All right, so looking at this very first one, it's 3 terms. It has to be a perfect square trinomial. So that means I can take the square root of the first, square root of the last. See if I can condense this a little bit more. So I'm going to have x and 4. And I just want to keep the sign of the b value. So x plus 4 squared. So that's your final answer. If only they were all this simple. All right, number 2, once again, perfect square trinomial. So I'm going to take the square root of the first, square root of the last. So 4a and square root of the 1, which gives you 1. Keep the sign of the b. So 4a plus 1 squared. So remember, this only works if the first and the last term are both perfect squares. Otherwise, it doesn't work. All right, number 3. So square root of the first, square root of the last. So square root of 49b squared is going to give you 7b. Square root of 1 is going to give you 1. Keep the sign of the b value, so 7b minus 1 squared. All right, number 4. All right, notice how your very first term here is a negative. So that means we have to factor out that negative first. So I'm going to have a negative parentheses h squared minus 14h plus 49. So the first and the last, so h squared and 49, those are both perfect squares. So I'm going to do the trick. All right, so the square root of h squared is h. Square root of 49 is 7. And I'm going to keep the sign of the b, which is negative, which means I'm going to have negative h minus 7 squared. All right. So you may have to factor out the greatest common factor before you can actually do the trick. Just FYI. Okay. Number 5. All right. So now for this one, 36c squared and 49 are both perfect square trinomials. Nope, they're both perfect squares. So I can take the square root of both. So I'm going to have 6c and 7. Keep the sign of b. So 6c plus 7, all squared. All right. Number 6. So if you notice, this is only 2 terms, so this has to be a difference of squares. All right, so for this one, it's going to be square root of the first, square root of the last. So the square root of 81k squared is going to be 9k. Square root of 4 is going to be 2. So this is where you have one with addition and one with subtraction. So you're going to have 9k plus 2 and 9k minus 2. So notice how these problems are literally done in a matter of seconds. All right. Number 7, once again, difference of squares. So square root of 121v squared, square root of 81. So square root of 11, nope. Square root is 11, 11v. And then square root of 81 gives you 9. So once again, one with addition, so 11v plus 9, and another with subtraction. And there's your answer. Hello. Boom. All right, number 8. So if you notice, we have a degree of 3 here. So you need to factor out a GCF. So we can take out an R. So if I take out an R, we're going to have 4R squared minus 1. Then we can do our perfect square trinomial. No difference of squares. All right, so square root of 4R squared is 2R. Square root of 1 gives you 1. All right, so remember, 1 with addition, 1 with subtraction. So you're going to have 2R plus 1 and 2R minus 1. And then you also need to write that R from the very beginning. So don't forget that R. That's going to be on the outside.